Okay, so now the explanation. So you have the program switches buttons here. So program 1, it will go into this RS-NOR latch and it will select it. Now program 2 also goes into the RS-NOR latch. We have program 1 selected. So if you press program 1 again, it will do nothing. But if we select this one, it will send a redstone signal into this torch, deactivating this torch, activating these torch, going into there, and then it's just a response system with a redstone torch there, which illuminates the lamp. Now the calculator, you have a T flip-flop. This is Minecraft Bedrock, so you can't do traditional ones. You have to use these, where it cycles items and detects it. Then it will lower these pistons so that current can travel through. Now here you have the calculator inputs. Now they will run all the way around here, all the way around this bit. I'll explain it later. Under here, and into the ALU, which I've done in the calculator video. But this one is a bit more simplified and works better. Yep. Now, okay, so this one activates the clock. We have the clock here. It will go around in circles. Now clock response. So whenever the clock pulses, it will send an input back here from this torch, which the clock is going into. Now when you select it, there will be a T flip-flop, which will activate these pistons going down, so that this, which is a counter, explain that later, so that signal can go through. Now the counter is then activated, and what it does is whenever you send an input into here, these will switch off and it will carry on to the next one. So this one is off, and then after the next pulse this one will be off, which means this one will be on, and it will go into that. Now let's go back to the program select. So if you have program 2, it will extend these pistons and it will cut off the signal from program 1, which is here, and will make a signal go into program 2, which is here. Now what this is program memory, and it is very messy. That's all I have to say. So in here you have a signal, and it is going into this torch right here, which then goes into a line into the ALU. Now this is basically what you call ROM, or read-only memory, where you have to yourself program this by hand. But what RAM does, which I don't have, so this technically doesn't qualify as a computer, what it does is it can read memory, so you can send in an input, it will save it to the memory, and then you can access it. Unfortunately, this doesn't do it. But this is what is used to save program memory. So this is program 1, so count a sequence of 1. So 1, 2, 3, 4, 5, 6, all the way up to 30, and going to the other output. So once it goes above, I believe, 16, it will have to go through the ALU and be added together. Now the way I did this is very messy. So program 2, instead of primarily going into this line, it will go into this line on the side of the ALU. So it will count the Fibonacci, but there's one term which needs another addition. So therefore, there's this whole line which goes into here. Now I built all these other ones which are not used, just in case I ever wanted to change the program to something else. So then it would be easier. This extends all the way here. Now when this counter is finished, it will return to the first position, and it will shut off the clock. So then you have to turn it on again. In a normal computer, you have one button which manually switches on and off the clock, in turn switching on and off the computer. Now you have this one powered, so this block is up, so it will never send a signal through there until you hit the clock, and this one will get powered, so the first one in the sequence will be activated. Now I think that's it, and I think this is all that there is to it. Now I have built a design which should make it a proper computer, but I'm having trouble adjusting the inputs with the clock, and it's really confusing. the programs work is just the calculator and clocking information to the RAM, especially from output. I want the output to clock to RAM, so then it will be saved and you can do it like in a normal calculator in real life. And instead of 2 programs, we have 3, but I'll make a video on that as long as I can make it work, or I'll just show the failed progress of it. So there we go.